Hi, my name is Dr. Martin Rosen, and I'm a chiropractor. We specialize in pediatrics and chiropractic cranial adjusting. And I'm very happy to be joining you for this Tummy Time Summit. What I'd like to talk a little bit about is the first couple of years of a child's life. In the first 2 years of a child's life, it's probably the most important time of neurological development. The brain grows 101% in the first year, while 80 to 90% of the gray and white matter is laid down at this time. Disruption of any normal developmental process at this point in time can have far-reaching effects that may be manifested for the rest of a person's life. Certain motor and sensory skills set the groundwork and foundation for normal development. These are pre-programmed into our nervous system and are set to develop at very specific times. Glitches, skips, or compensations to this process can create aberrant compensatory patterns that make life more challenging as neurological development increases. If these milestones in development are not manifested, there's a greater propensity for the child to develop neurological, functional, social, and emotional issues later on in life. I want you to take a look at this motor function chart. And as you can see, starting from birth all the way through the first 6 years of life, where the most prominent pre-programmed proprioceptive feedback loops fire off, there are specific things that your child is supposed to be able to do based on mobility, language, and manual competence. These all build on each other. If they do not build on each other in a progressive manner, then functional and developmental issues can often occur. The cutting off point or the jumping off point is basically between 12 to 17 months. At this point in time, if these milestones are not reached, you can bet that there is a high propensity for neurological or functional issues to occur as life continues on. The other part, next chart we want to look at is sensory functions. Again, the same thing. These abilities and these functional capacities are pre-programmed into the central nervous system. And at certain points in time, they're supposed to fire off. And the whole idea behind that is to allow for the developmental process to occur naturally. Again, we're looking at a 12 to 17 month period where this is a cutoff point where if there are issues here and these stages are not reached, as the child develops into an older child around age 6 or so, you'll start to see developmental and neurological problems. Often that even occurs at age 3 or before that period of time if these functional parameters are not met. So infant developmental milestones are monitors of how the child's nervous system is developing and adapting to its environment. The first 2 years of life, as we talked about, 80 to 90% of the groundwork for the developing nervous system is being laid down. Synaptic development, which is the ability of the nervous system to make connections, is advancing at an unprecedented rate. The peak development is actually at 8 months of age and is driven by external and internal stimulation. The whole idea of developing these synapses is to make a pliable, functional nervous system. We develop a high level of synapses or integration of our nervous system in the first couple of years of life. And then over the years, as we start to use parts of it or not use parts of it, these start to pair off. So we have an overabundance of the synaptic development that occurs very early in life so that there is basically a reserve for us to use or to pair off in case there is damage or parts of our nervous system that we don't use as much. Each milestone is dependent on two things: proper neurological pre-programmed feedback loops and the ability to build on the previous milestone. So if you look at this chart, you can see right here, the highest level of synaptic development occurs around 8 months of life. We continue to make synapses, which is why we still have a neuroplastic nervous system for the rest of the life, but the process slows down significantly as we age. So where does tummy time fit in? Well, as your child can hold up their head, a reflex known as the visual proprioceptive writing reflex is activated. This means that your child is now able to adapt to gravity and begin to create a motor and balance or vestibular system, what that is known as, that they will use for the rest of their life. The ability to lift their head sets the stage for them to create mobility and experience their environment independently for the very first time. Think about that. Once your child is able to lift their head, they start to be able to explore the world in a whole different way, take on a lot more input, and actually be able to see a lot more what is going on around them. So we lift our head, can lay on our stomach, we roll over, we sit up, we crawl, we creep, we stand, and we walk. These are all, again, pre-programmed processes that occur within the central nervous system. At the base of the brain, an area called the brainstem contains these pre-programmed proprioceptive, which are how our body determines where it is in space, feedback loops, which are responsible for most of our motor development. The brainstem consists of the medulla oblongata, the pons, and the midbrain. It contains nerve connections of the motor and both the sensory system from the main part of the brain that communicate with the rest, what is also known as the peripheral nervous system. So this area in the lower center of the brain is what gets triggered as soon as we can start to not only come onto the planet, but as soon as we can start to lift our head, this area starts to create a balance mechanism within the body that we're going to be using for the rest of their life. Along with the motor and sensory development necessary for these milestones to be reached, as social development is also tied into the process. And what we mean by that is at 3 months, we're starting to make deliberate responses and calm interest in other people. And this is with the ability to hold our head up, lay on our stomach, look around, and visualize our world. By around 5 to 6 months, when we are now able to start to actually begin to sit up, we interact more with the outside world. Emotions like joy, surprise, and frustrations become more prominent. And now we're sitting up, we see more of the world, we can turn, we can reach, we can grab things, we're much more mobile. By 10 months, and of course, in this period of time, we already started to learn to crawl, we try to understand what others are interested in. Again, as we get to explore our world, take in more input, and our nervous system develops more, we are now able to do more with that system. And now we're trying to understand the people around us, not just our own primal needs. And we'll talk about primal reflexes in a little bit. But by 18 months, we are now walking, able to get around, and have a level of independence that we've never had in our lives before. And basically what this means is we can develop self-awareness. We develop complex emotions such as pride and defiance, right? We know about the terrible twos. It's a very common time. And part of that is a developmental milestone that we all reach as we start to, again, be able to become more mobile, explore our world, and integrate our nervous system. So the ability to become mobile is tied with our ability to explore the world, take in more information, and begin to codify that into an adaptive, healthy nervous system. Any interference or interruption to this process will affect the developmental underpinnings of a child's nervous system, leading to long-term compensatory changes. These changes, especially those established in the first 2 years of life, can alter a child's adaptability and neurological thresholds for the rest of their lives. So think about what we're saying. We're saying these first 2 years, the first things that we start to do, lift our head, lay on our stomach, roll over. These are things that start to trigger and set up a process that we're going to be using for the rest of our life that help create a nervous system, its adaptability and its thresholds forever and ever and ever. So after age 2, the period from 2 to 6 is the next most influential period of growth and development. At the same time that our nervous system is developing, our brain is creating different brainwave patterns to be able to take in more information. So as the brain records all sensory experiences, as well as learning and motor sensory developmental skills, we pick these up through our environmental and social cues, which is why it's so important for us to become mobile, to be able to move around, to be able to lift our head, to be able to explore our world. Damage at any stage prior to the preliminary development of these functions will cause compensatory patterns to either be learned or to occur naturally to allow us to interact with our environment to the best of our ability. We are fault-tolerant mechanism. And what that simply means is that if there is damage at some part to our nervous system, whether we're older or whether we're younger, what we're going to do is try and compensate for that damage. The problem is when it happens so early in childhood that these compensatory patterns will decrease our adaptability threshold, or basically make us have to compensate more and more as time goes on, which is why often developmental anomalies will occur around age 3, 4, when the front of the brain, the prefrontal cortex, is kicked in. And basically what it means is the brain now has to function at a higher level. So if it's already compensating, it has a much harder time to function at that higher level. In 1992, there were a number of studies done on functional capacity, but in 1992, one of the studies showed that traumatization of the suboccipital structures, which is at the base of the brainstem over here, which is the area where the pre-programmed proprioceptive feedback loops are, that those structures, if damage occurs, it inhibits functioning of this feedback loop. And therefore, our motor development, which is, of course, pre-programmed, cannot develop normally. And again, as I just mentioned, these systems are fault tolerant and able to overcome considerable difficulties and restricted working conditions. But the price of this is a reduced capacity to absorb additional stress later on. So again, we pay a price for this. These children may show only minor symptoms in the first months of life, but later on at the age of 5 or 6, they can suffer from things like headache, postural problems, diffuse symptoms like sleep disorders, or being unable to concentrate, which back in 1992 basically meant unable to concentrate was the same thing as ADD, ADHD, sensory proprioceptive, sensory integrative disorders. It was about being able to process information correctly. So if there's traumatization from this moment in time, we may develop compensatory patterns that make it much harder to function in society as we get older and older. Also, development of balance and coordination is the foundation of postural mechanics that will depend on for the rest of our lives. The process starts immediately after birth, and its foundations are established in the first 18 months of life. Each stage of development must build on the previous stage to allow us to establish an integrated nervous system. So it is a stepping stone. One milestone is a stepping stone for the next, is a stepping stone for the next milestone. So just take a look here and get an idea of what's happening in just the first year of life and over the next couple of years, the second year in life as well. What is happening? We're creating 1,000 to 100,000 synapses per neuron. The brain grows 2.5 to 3 times its size since birth. Its total volume increases 101% in the first year and about 15% in the second year. The cerebellum, that base of the brainstem that we're going to talk a little bit more about, grows 240%. And it's so important because the cerebellum is your mainframe computer. It is where all the information gets processed through and is distributed through the rest of the brain. And also the information from the brain comes through that area and is distributed to the rest of the body. By age 2, 80 to 90% of the adult volume, especially the gray matter that you're going to have for the rest of your life, is there. So think about that. All the cells that you're going to need for the rest of your life, 80 to 90% of them are formed in those first 2 years. By age 6, you've integrated, if you remember those motor and sensory charts we showed you a few minutes ago, if you remember by age 6, 90% of your motor and sensory system is integrated. So the system, the nervous system that you have and how you deal with the world by age 6 is often the way you deal with the world for the rest of your life. Finally, full myelination, or what are called the intercommunication neurons, where the brain basically talks to each other back and forth in a much more clear pattern, occurs by age 10. But if the baseline has been damaged, especially the first 2 years or even up to the first 6 years, what you're going to have is a brain that's going to have compensatory patterns and not going to be able to coordinate or integrate information as easily as possible. So the cerebellum, we just talked about a moment ago. This brain is imperative to normal functional development. All right. It is located just below your cerebellum and behind the upper portion of your brainstem. So it's right at the base of the skull where your head meets your neck. It is critically involved in motor coordination and balance. Besides its involvement in motor coordination, it is also implicated in a wide range of other cognitive abilities, including planning, set shifting, language abilities, abstract reasoning, working memory, and visual spatial orientation. It also has reciprocal, which is other projections into the frontal, the front of the brain, the parietal, and again, the occipital association cortex. So the cerebellum is, as I said, your mainframe computer that ties all the peripherals. If you look at the frontal bone, parietal, occipital areas, those are the peripheral systems, basically like you have when you have your computer or a mainframe computer and you have other computers hooked up to it or laptops or whatever it is that you have hooked up to that mainframe computer. The cerebellum is that mainframe. This, along with the cerebellum's rapid growth, which we talked about, 240% in the first year, suggests that its proper development is a prerequisite for specific aspects of later cortical development. So basically what we're saying is the ability of the brainstem and the cerebellum to start to trigger off proper neurological processes in those first 2 years of life are going to be important to the development of the rest of the brain. The occipital lobe, which is based, and you can see here in yellow, is where the visual cortex is located. And that is in the occipital lobe of the brain, the back and lower portion of the brain, right above the cerebellum. What is so important about that is it is where the visual proprioceptive writing reflex is triggered. And this is paramount to keep our brain, eyes, and body in relative balance with each other. It is triggered, and this again, listen to this, it is triggered as soon as an infant can hold their head up. So the ability to hold their head up, which is is part of what tummy time is all about, strengthening those posterior neck muscles, allowing the child to be able to extend their head up. That triggers the visual proprioceptive writing reflex, and this should occur within the first 2 months. By this point in time, an infant consistently relies on visual cues to orient their head and body. So this is the first time the child is going to be able to adapt to gravity and start to compensate for gravitational force